Good morning, class. So my name is Teacher Gerald, and beside me we have.
Hello everyone, I'm Teacher Hui.
Hi everyone, I am Teacher Joanne, and beside me,
I am Teacher Holun.
hello.
Okay, let's start the class. So we start with Teacher Joanne.
Okay, so good morning, students. So everyone, follow me to our class, and you can start our class. So is
Okay,
everyone here?
teacher.
Okay. Sit on your respective seats. Okay, I believe you have played before using this Kumu space. All right. So, how is everyone? Welcome back. How's your weekends? Do you enjoy?
It was
Yes,
fun.
Yes.
Okay. All right. So, I hope everyone is excited and ready for today's lesson. Do you get your pencils, your marker pens, and your paper ready?
Yes,
Yes,
teacher.
teacher.
I'm good.
Okay, good. All right. So, I need everyone's attention on the screen right now. So, can anyone guess what is happening in the two pictures? What do you see and understand from the two pictures? Share your answers with us by scanning the QR code or go to www.menti.com and use the code 74931697 to type in your answers. And I will also share it on the chat.
okay, teacher.
Okay, teacher.
Give me a moment. So while others, if you can scan the QR code, you can scan the QR code right now. All right. So I'll give you from 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, let us see the results. What is happening actually? All right, the pencil is bent, someone said, and there is refraction, is it? And the arrow is inverted. Yes, very correct. All the students, very good observation. But right now, anyone can guess what are we going to learn about? Anyone?
Refraction, teacher. Is
Are
it?
you sure? Okay,
Yeah.
so right now, for the moments of truth, today we are going to learn about. Drum roll, please. Okay. We are going to learn about 8.4 Refraction of Light. Congratulations to Holun and those who have answered correctly. Give a round of applause. Thank you very much for participating and sharing your answers. So right now you might be wondering, what is refraction of light? And why was the pencil bent in the picture? Is it really broken? Do you think is it broken?
No.
Now to answer the question, let's watch this video.
Oh. It is because of refraction of light. Refraction of light is the change in direction of light when it passes from one medium to another obliquely. So, what do you think are the two media here? You don't know? No worries. I will tell you. They are air and water. Oh. When the light rays coming from the tip of the magic wand pass from water to air, they change their direction. That is, they get refracted. When these refracted rays reach our eyes trace them backward as straight lines. Due to this, the rays appear to come from a point slightly above the original position. Hence, the magic wand appears to be bent in water.
Oh.
Similarly, like the magic wand, a pencil appears to be bent in water.
Alright students, now we know a little bit about refraction of light and why does a pencil look bent in water. Do you know that even the twinkling stars in the night is also because of refraction of light? I bet everyone is interested to know more. So, without further ado, allow me to introduce to you on what are the learning objectives of today. So, at the end of the lesson, students should be able to 1. Generalize that refraction occurs when light moves through medium of different densities. So remember, it is different densities. So if light moves through mediums of similar densities, then no, refraction does not occur. Refraction only occurs when light moves through medium of different densities. Remember, students? So the second one is to draw a ray diagram to show refraction of light when light propagates from one medium to another medium of different densities. So when light enters from one medium to another medium of different densities, then refraction of light occurs. And we will learn a little bit on how to draw the ray of diagram. The third one is to generalize the relationship between the angle of incidence I and angles of refraction R when light travels from a medium of low density to a medium of high density. So later we'll be able to know the relationships. What are the relationships? Will the angle of incidence be bigger than the angle of refraction or vice versa? The fourth one is to justify the application of refraction of light in daily life. As we all know, the pencil look bent in a glass of water, as well as the twinkling stars in the night. And now we are going to learn even more about it. So without further ado, let us conduct an experiment by inviting Miss Holun. She will be guiding students on how to show that the arrow is reversed. So let's give a hand of applause to her.
Okay, thanks Teacher Joanne. Hi students. So now at our experiment time. Woohoo! So just now you guys already saw that the directions of the arrow is reversed, is it? Yeah, so now is your time to try. So before we start our experiment, let us move to the round table. Is it okay?
Okay.
Okay.
Teacher Holo, we want to see your face.
Okay. I have already broadcast myself. Okay. Alright. So now we will do an experiment regarding the refractions of light. So let us take out the materials. So the materials that we are used in this experiment are the paper, the glass, the marker pen, and also the water. Okay, so if you guys prepared already, please give me a happy reaction. Okay,
Wait,
thank you,
teacher, I'm not
students.
just show my happy reaction.
Okay, I see already. Okay, thanks, Joanne. So now teacher will explain the procedure. So everyone please follow the procedure. Don't do first, yeah? So I will give you time to do. We listen first and then we do. Is it okay?
Okay.
Okay, so let me start. So step 1, we need to draw an arrow point to the right with marker pen. Yeah, like this picture. Okay, step 2. So after that, we need to put the glass in front of the drawing. So everyone please make sure to handle the glass carefully. Is it okay? You make sure don't put it at the edge of the table. It's so dangerous. So after that, we fill the glass with water. Then we look through the glass of water and observe what happens. After that, we'll record your result in the table. So now everyone understand?
Yes.
Okay. So students, now I will give you 5 minutes to do the experiment and we can explore the changes. So if you have any problem, you can ask teacher. Don't be afraid. So now is your time.
Teacher, look. Come here.
Yeah,
I want to show
yeah.
you my big cup. See
Wait,
my
wait,
big
wait.
glass of water.
Okay. Okay, later I ask Joanne to share your finding to us. Is it okay?
Okay.
Okay, just now I also saw that Hui show
Arrow, I have drawn my arrow.
Oh, okay, I see already. Okay. Okay, so now 5 minutes time's up already. Now we invite Joanne to share your finding to us. Is it okay? So So Joanne,
Wait,
now you
teacher,
can broadcast
wait,
yourself.
wait. Okay, I'm drawing the
Oh,
arrow
I'm
very
drawing.
fast.
Okay,
Okay, done, teacher. I will
Okay, okay.
broadcast
Yeah, you
myself.
broadcast yourself.
See my big cup
Big
Wow.
face also. Yeah. Okay,
and
okay.
my arrow. Okay, so the
Yeah.
arrow is like this. Turn it. Oops. Teacher, too much water already.
It's okay. Ooh,
Wow.
Jared, can you tell us what is happening just now?
Yes, as you can see, the arrow actually changes direction. Now it's pointing to the left.
Oh, yeah. What is it? What is this happening, Hui?
I think this is about the topic we're going to learn, refraction of light.
Okay, yeah. Everyone, please give a clap to yourself. Okay, well done. So now we only know it is because of refractions. But how does it occur? Yeah, I believe you guys are also curious about it. Now, teacher Jada will explain to us the concept of refractions of light. So now, let us go back to the center. Go, go, go.
Okay.
Okay.
Thank you, Teacher Olun.
Okay, welcome.
Hello,
So now-
Sir Gerald.
Hello. So now I will explain about the concept of reflection. So let's wait for Teacher Hui to share the screen, the slides, then I'll explain further. So first off, you can see here, let's observe how light refracts. So through this link, it'll link you to a simulation which shows you how light refracts.
Okay, I can't wait.
Okay, give us a moment. I know you students
so
are very
excited.
excited. Yes.
Yes.
Okay. So in this simulation, the black box represents the light source, and the top layer is actually air, and the bottom layer is water. So let's see what happens when we press go. The light is traveling through, and when it hits the water, it refracts, and it points downwards.
Wow.
But this does not only apply to air and water. Let's try with different substances, such as water and oil.
Oil.
Yeah. As we can see, it also refracts downwards. So now you've seen it firsthand. I'm going to explain to you why this happens.
Okay.
So let's go back to the slides and I'll show you what I mean. So let's use this analogy of a car. When driving a car from a smooth road to a rough surface such as mud, it begins to slow down. But it doesn't slow down uniformly. If you see here, the car is entering the muddy surface at a diagonal, and it begins to curve away from its original direction of motion. This is because when the front wheel enters the muddy surface, whereas another wheel actually is still on the smooth pavement. So the one that enters the muddy surface actually slows down first, which causes it towards the slowed down wheel. So if you go to the next slide, this is similar to the phenomenon we call refraction. So when light travels from a region of low density to a region of high density, the speed of light reduces and its direction bends towards the normal. So similarly to the analogy of the car, the low density represents the smooth surface and high density represents the muddy surface. So when we talk about refraction, we must also have a look at ray diagrams. So what are ray diagrams? Do you guys know what are ray diagrams?
No, teacher.
Okay, I'll show you. So ray diagrams are very important. They are used to help us understand how refraction works, and we use it to so that we can draw and see how light refracts. So inside a ray diagram, we have the angle of incidence and the angle of refraction. So similar to the example before, example where light is traveling from a low density medium to a high density medium. So the angle of incidence represents the angle formed between the incident ray and the normal. So the angle of refraction, on the other hand, is the angle formed between the refraction ray and the normal. Okay?
Okay.
So if you look carefully, what occurs to the angle with the normal when the light enters the medium with high density? So Joanne, can you explain to me what happens and how can you compare the two angles?
I think the angle of incidence is larger than the angle of refraction.
Yes, correct. So if we go to the
Yay.
next slide, so angle of refraction is smaller than the angle of incidence, or in the way that Joanne phrased it, the angle of incidence is larger than the angle of refraction. When drawing a ray diagram, every ray diagram has a normal, incident ray, refracted ray, and at least two mediums of different density. And one of the most crucial parts of a ray diagram is the normal. So the normal is always drawn perpendicular or 90 degrees to the line separating the two mediums, as we can see here. So now I'll show you how to draw a ray diagram. So if you observe this diagram right here, first you have to draw a straight line. So that straight line represents the boundary between the two mediums. After you've drawn a straight line, you must draw the normal. So normally the normal is a dotted line that is perpendicular to the boundary between the two mediums. So similar to this example, let's take a light source that is from the medium of less density as the top layer, shining light to the medium with higher density at the bottom layer. So if you see here, the moment the light hits the boundary normal, it begins to curve towards the normal. So this is how you draw a ray diagram for refraction from low density to high density. Okay, does everyone understand?
Ooh, okay.
Yeah.
Yes.
Okay, can anyone show me their works?
Yeah, teacher, I can show you my drawing.
Okay, let's have a look.
Okay. Everyone see my drawing clearly?
Wow, so pretty.
Yeah, the first one is, okay, so the light ray will travel from the more dense to less dense air. Okay, so the light ray will reflect away from the normal. So the second one is, okay, from the less dense to more dense, so will reflect towards the normal. The third one is, just now the teacher
Wow.
teach will be perpendicular. Yeah, this is my drawing.
Wow, nice job, Lee. Everyone give a round of applause.
Amazing.
Amazing. Okay, so now that we all have understood the concept of refraction, let's go back to the experiment that we did just now. So in the experiment we did just now, the arrow suddenly turns to the opposite direction. So can anyone tell me why?
Teacher, we don't know. We just
You
know
don't know?
it's caused by the refraction of light, but we don't know why.
Yeah.
Okay. Don't worry, I'll explain it to you, okay?
Okay.
So when the light passes through the water, it begins to bend, correct? So the light from the head of the arrow and the light from the tail of the arrow, when it passes through the water, is to bend and it overlaps each other. So when it overlaps each other, it goes and bends to the other side, which causes it to cross over, and arrow direction becomes opposite. Can everyone understand?
Yeah,
Interesting.
Wow,
Yeah.
that's the reason. So we change direction.
Yes.
Yeah.
Okay. So that's all from me. Now I'll pass it to teacher Hui to continue.
All right. Thank you, Teacher Gerald. Okay. So does everyone understand the topic just now?
Yes.
Yes.
Yeah, okay, very nice. So now we are going to relate the phenomena that happen in our daily life to the refraction of light. Hi, student. Are you guys ready for it?
Yes.
All right. Okay. So now we're gonna focus on the formation of rainbow. So I have a question now. When we usually see a rainbow, can Holo answer me?
Is it after raining?
Yeah, correct. So we can see the rainbow after raining, right? But why? So now there are two elements that play a main role in the formation of rainbow. The first one is sunlight and the second one is raindrops. So rainbow are formed when light from the sun is scattered by the raindrop through refractions. So now let us see into detail how the rainbow is formed through the refraction of light. Okay, everyone, just see on this picture. Okay, so when the light travel from the air into the raindrops, so it will change direction because it passed from the less than medium, which is air, into the denser medium, which is raindrop. So now I have a question. When light passes through the less than medium to denser medium, it will refract towards the normal or away from the normal. Can anyone answer me?
Mm, is it refracted towards?
Yeah, it's a good try, Joanne. Correct. Okay, so once the reflected light enter the raindrop, right, it will reflect it off back and then refracted again as it exists. So at this time, light ray will refract away from the normal because it passed from the raindrop, which is denser medium, to less than medium, which is air now. So this is how we see a rainbow through the refraction of light. So now let us watch a video to have a better understanding about how rainbow is formed.
A ray of light is made up of the same 7 colors seen in a rainbow. This is seen when a ray of light is shone at an angle through a prism, a triangular-shaped piece of glass. Light slows down as it goes from air to glass and causes the ray of light to bend. This is called refraction. Each color in a ray is bent at a different angle, allowing 7 colors to be seen. The red light gets bent the least, while the violet light bends the most. Sunlight, therefore, is key to the science of rainbows. Light travels more slowly through water than air, so that raindrops act as prisms, bending, separating, and reflecting the light that shines through them. We can see a rainbow because the separated light is reflected toward our eyes.
So student, is that amazing? Are you guys understand?
Yes,
Yes.
teacher.
Alright, so now we have a small activity section called Exploring Time. So here we have 4 phenomena. As you can see, this is all about the phenomena of refraction of light. A pencil look bent in water, coil appear shallower than its actual depth in water, object appear larger when looked at through a water drop, and finally, image cannot be seen properly through a solid eyes. So now I'm gonna to divide all of you into 4 groups. Okay, so Hollow will be the group 1, Joanne will be the group 2, and also the Gerard will be group 3. Okay, so everyone in the group need to do this experiment and prove it. Okay, so after that, you guys need to taking the picture and upload your picture inside the Jamboard link I given in the chat box later. Okay, so are you guys ready?
Yes, teacher.
Yes, teacher. I want to
Okay,
explore
so
now.
now everyone move to the round table beside you. Okay, just sit on
Bye,
your
my
I want to
friend.
group with Holun. Why am I group 2?
okay. So I will guide you guys. If any problem, can just ask me. Okay, so are you guys ready?
Yes,
Yeah.
teacher.
Yes, teacher.
Okay, so you may start now. Okay, I will give you guys 5 minutes. Okay, it's just an easy experiment. Okay, you guys can try it. So now I will share the Jamboard link. Okay, let us see who is share their photo now.
Teacher, I already shared my photo.
Oh, Holland, you from group
Yeah.
1, right? Okay. Wow, your photo is nice. So what we can see here, everyone can see or not? The pencil look bent. Is it clear? Everyone can see?
Yes.
Yes.
Yeah, so this is how the refraction of light cause this pen become look bent. Okay, so now look at the group through. Okay, the group 2 haven't outlook yet. Okay, now we look at the group 3. Wow, okay. The group 3 already upload their photo. As we can see here, the image looks clearer and bigger. Okay, when we look through the water drops. Alright, so now I have a question. I want to invite representative from group 1, which is Holum, come to share with us how this phenomena which the pencil, why the pencil will look bent. Okay, can you come to share with us, Holum?
Yes, teacher.
Alright.
Okay, teacher can let me broadcast myself. I want to show it to my friend. Okay. My name is
Hello.
Paulun. So now I would like to share my finding. So when I put the pencil into the water, it looks bent, but actually it is not bent.
Wow.
I think it is one of the phenomena of the refractions of light. Maybe the air is less there and the water is denser. So when the light passes through, it will become like this. Where is teacher?
Yeah, okay. Holun, you did a really good job. Okay, it's very clear your photo and you do like put a good effort. Okay, so now, so okay, so the light will bend as it passes through the one medium to another medium of different density, right? So the light when pass from the air to the water, so it will bend. Okay, the light red will bend. So this is why we see the pencil as the bend. Okay, so now are you guys like excited with this session? Like understand more about
Yes.
Yes,
refraction of
teacher.
light?
I
Yes.
learned a lot.
Okay, all right. Thank you, students. So now I will pass the session to Teacher Joanne again.
Alright. So everyone, hello. Hope you had fun. Come, follow me. Let's go to this table over here. The one with yellow chairs.
Okay,
Yes.
teacher.
Teacher.
Come here. Okay, so allow me to share my screen. Hold on a moment. All right, so this game is called Paddle Your Way to Victory. It's a gaming game. It's a gaming activity where there is questions for you to answer. So it's a little sort of quiz to test on your understanding on what you've learned so far. So how to play the game? So at the table, you can click on the link there. So, or I will also be sending the link later in the chat box. So the first step is to start the link, to start the game, you have to write in your name, your full name. Okay, so for example, like me, I'm Miss Joanne, so I'll write Joanne. So after that, click on the button play to start the game. And the third step will be, so anyone here who are computer users or laptop users?
Me, laptop user.
All right. What about mobile? Who are using mobile devices?
Using
Me,
mobile,
Teacher.
teacher.
Alright.
Yeah.
Okay. So for laptop users, press the keyboard keys up to move forward, left to turn left, right to turn right. You can move your bicycle when you are cycling, and down to move backwards. So same for mobile devices, there will be buttons of arrows indicating up and down to go straight or move backwards. Same goes to left and right. So for the fourth step, after you've known everything, what happens if, let's say, you cycle and suddenly you crash? So when you bang the corners, the speed of the cyclist will go back to zero. That means it will decrease. So you have to start all over the speed again. So the fifth step will be as the cyclist cycles. So in normal life, as we cycle, sometimes we get tired because a lot of energy is used. So same goes to this game. The energy bar will decrease. So to speed up, you must get the energy boosters along the race. So the energy boosters you can see from the pictures. So in every energy boosters, you must answer the question correctly. So all the questions will be based on what we have learned, that is refraction of light. all the things that we have learned. And the amount of energy booster depends on the time taken to answer the question correctly. So you must remember to answer correctly, right? And the last step, okay, the last step is at the end of the race, the scoreboard list will be displayed. So those with the highest speed will be at the top of the list as shown as in the picture. And so what are we waiting for? So let the race begin. So let's
Okay,
put what we have learned to
teacher. I
test.
can't
Yeah.
wait for it. Teacher.
See you at the finishing line.
Teacher,
I
I
will be
have a
sending.
problem.
Yes.
What is the play code?
All right. So the play code is JMJ, all capital letters, SWK. I will be also sending them in the chat. So you can check it out or scan the QR code.
Okay, teacher.
Okay.
Ooh.
Okay, hope you're having fun.
Yeah.
So while waiting, wow, I hear somebody crash, is it?
Teacher, just now I
Yes?
answered correctly for question 1. It's so interesting, eh?
Wow, all right. So, okay, students, I believe most of you have already finished.
Yeah,
Allow me
teacher,
to share.
ready.
Yes, I will right now share screen on an overview of today's evaluation, a mini evaluation through a game. So we have Gerald here. Okay, he got correct 6 questions. So
Wow.
let us see. Oh, all right. So he got this incorrect. It's okay, never mind. The greater the angle of incidence, the bigger the angle of refraction. Do you think this is true or false? Gerald, can you answer me whether is it true or false?
Well, now I think I know the answer is true.
Yeah, good. And if an object in the air is viewed from beneath the surface of water below, where does the object appear to be? What do you think the answer is? Anyone?
Oh, I think I know, teacher. I
Oh,
think
all right.
it is the object appears above its actual position.
Yes, correct. All right. So I believe right now you can play again, Gerald. With all the correct answers, you can beat the scoreboard again, but play it after class, yeah? And we have Holun. All right, she's still trying. Never mind. And we
Teacher, how
have
about me?
Hui Yi. Okay, let's look at Hui Yi's. All right, so Hui Yi must have missed some of the energy boosters. It is okay, you can play again
Okay.
later after this class. So we have the light ray is reflected away from the normal when the incident ray moves from a more dense medium to a less dense medium. Do you think it's true or false, Hui Yi?
Teacher, this one just now I careless. I think it's reflect towards the normal. Is it wrong?
Oh, okay. It should be refracted away
Oh,
because it's
sorry,
from
teacher.
more dense to a less dense medium. So the statement is true.
Oh, okay.
Okay.
Now I know. Thank you.
All right. So that's all. Thank you for those who have played the game. All right. So now we are almost going to end today's lesson. We are going to have homework time.
No,
teacher,
teacher.
I don't want.
Never mind. You can learn. We can evaluate you on how you have learned thus far. Very easy homework. So, in your words, what do you think is refraction of light? So, please write them in the Padlet. And then I've already sent the link in the WhatsApp group. So, in your words, you can please write what is refraction of light and also a reflection on today's lesson. Please state what you have learned, what you have feel, and any questions. How do you feel of the whole lessons? Is it interesting? Is it fun? Or you feel unsure about certain things? So you can write down any questions. Okay. Oh, and we have Annie. Annie have already submitted her reflection for today. She feels happy, and I hope everyone feels happy too. But it's okay if, let's say, you have questions or you feel sad, you can just share it in the Padlet. So, can I have a representative from this class? Anyone wants to share on your reflection for today? On what you've learned?
Me, I can share.
All right. Yes, Wei.
All right. So that today class is very exciting and engaging, especially the experiment part and also just now the exploring time. Okay, I learned a lot and very fun. So today I also learned about the what is refraction of light and how to draw Venn diagram, and important is the angle of incidence and angle of refraction. So thank you every teacher. I very enjoy this class.
All right, we're happy that you enjoyed the class for today. So, with that, we can say goodbye to each other. We will end the lessons for today.
Okay.
Bye-bye.
Bye, teacher.
Goodbye,
teacher.
take care, and stay
Thank you,
safe.
teacher.
Thank you for
Thank
attending the
you.
class.
Goodbye, my friends.